All right, so again, reminder of next week's schedule. You get to see me Monday, Tuesday, Wednesday, Thursday now. It's actually, you guys will see me Monday, Tuesday, cohort B, Thursday, Friday. Then after next week, you get to see me 4 days a week. Yes. I know you're excited. And then our lunch next week is actually an hour earlier than what we normally eat. So we'll have from noon until 12:25 as our lunch period. God darn it. There we go, stay. All right. So we're going to finish up lesson 14.3 today, talking about continuous functions now. And we'll use a little bit of that one-sided limit idea from yesterday to define what a continuous function is. So we call a function continuous if f is defined at c. In other words, we plug a value in, we get a value back. Okay. So f has to be defined. F of c is equal to a number. If the limit as x approaches c from the left is equal to f of c, and the limit as x approaches c from the right is equal to f of c. So in other words, these two limits are the same from the left and the right, so that's just the limit, and it's equal to the value of our function at c. So this is just a, I think it'd be easier to write it this way than these three, but so a function is continuous at c if the limit as x approaches c of our function f of x is equal to f of c. Things that can cause a function to not be continuous would be things like vertical asymptotes, a hole in a graph. If a function jumps, like our floor function or our ceiling function from trimester 2 maybe, those would be jumps. It jumps from one value to the next. It doesn't. So that's continuous function. If a function is not continuous, we use the term discontinuous. So just a terminology piece there. It looks like you're all interested in writing that down. All right, here we go. So for the function r of x is equal to x minus 2 over x squared minus 6x plus 8, determine the numbers at which it is continuous. Now, it's actually easier to find out where it's not continuous and then just say, well, it's continuous everywhere except. So that's going to be just an easier way of going at it. Use limits to analyze the graph of r near points where it is discontinuous, and then draw or sketch a graph of r. All right, so determine where it is continuous or discontinuous. I'm going to rewrite this down here. And the function will be discontinuous when the denominator is equal to 0. So for a rational function, we're going to look at factoring the denominator. So let's see, two numbers that multiply to 8 and add to -6. So we are continuous for all x values such that x is not 4 and x is not 2. So there's just again, one way you can write where it is continuous. Now what we're going to do is look at the limit. So for part B, use limits to analyze what happens. So I'm going to take the limit as x approaches 2, and I am going to write our function in its factored form. And as x approaches 2, well, we have this common factor that we can cancel. So as x approaches 2, it behaves like 1 over x minus 4. Actually, it behaves that way for any value except for 2. And so if I just plug the 2 in, this would be like 1 over 2 minus 4, which would be -1/2. So at the point 2, -1/2, we have a hole. So I'm just going to draw that in about where that would occur. For x equals 4, we're going to take a look at approaching from the left and the right. So if we take the limit as x approaches 4 from the left, and again, we can use that factored form, makes it a little bit easier to work with. So we have, well, if x was 4, what would our denominator be? 0. If you have a number over 0, that means it's going to approach either positive infinity, it's going to go off forever positive, or it's going to go to negative infinity. And the way you can tell which it is look at here if we approach from the left, from values less than 4. If I take a number less than 4 and subtract 4, what kind of a value am I going to get? Negative. So this approaches negative infinity. If I take the limit as x approaches 4 from the right, Now I have a number larger than 4 minus 4. And so when I subtract, I get a number that's positive. So it will approach positive infinity as we come from the right. This won't always be one positive, one negative. It happens because the denominator is to the first power. It's to an odd power. So this means that at 4, we have a vertical asymptote. All right, and then the graph. So the graph R of x will behave like the graph 1 over x minus 4 except at the point 2, negative 1/2. So it behaves just like a reciprocal function, except for where that hole is. So what does that mean? That means our graph is going to go like this. And like this. Or roughly like that. I know, Mr. Gingrich, that's a beautiful graph. Well, thank you. I honestly, I don't think I gave you any like this specifically as for homework, but it'd be more like this first part. Where is it continuous and where is it discontinuous? So the other type of function or another type of function that we have to be careful of with continuous and discontinuous is a piecewise defined function. So from our work way back last week, all polynomials are continuous. So linear functions, quadratic functions, cubic functions, all continuous. Sine and cosine are continuous for all real numbers. Even roots are continuous as long as the thing we're taking the root of is not negative. And then we have some special cases with logarithmic functions. But what we need to be careful of here, again, if we want to find where it's not continuous and then deal with everything else. So the values we're going to check for x are the values where the behavior of the function changes. So in this case, that's 0 and 2. So if we take the limit as x approaches 0 from the left, rewrite that. That would be the, we would put 0 squared because that's every time x is less than 0, we just square whatever x is. if we look at the limit as x approaches 0 from the right, we're going to, in this case, take 0 plus 1. And then compare our limit. Well, in this case, as I approach 0 from the left, I go to 0. As I approach 0 from the right, I go to 1. The limit does not exist, or the left and right hand limits are not the same, so it's not continuous at 0. To check at 2, again, we do the same thing. We're going to take a look at the limit as x approaches 2 from the left. So from the left, that's the x plus 1 function. And the limit as x approaches 2 from the right, and that's our 5 minus x function. In this case, the limit as we approach from the left and the right are the same value. And that's the value that we would get if we plug 2 in. If we plug 2 in, it goes to that 5 minus x spot. So the limit, it is continuous there. We're okay, it's continuous. So where is the function continuous? If I use interval notation, I would go negative infinity to 0. And 0 would be in parentheses because it's not continuous at 0. And then I would go from 0, and notice this is only defined up until a value of 5. So from 0 to 5. Again, I think I would be just as happy if you'd said x cannot equal, or x is discontinuous at 0 is fine, but I'm just telling you where it is continuous. I believe for your homework, the questions simply ask, is the function continuous at the given value? So it should be pretty straightforward. You know, you'll know which value to check, and you'll be good to go.